So as always, get your paper, get your pencil, let's get going. Last week, we started looking at polynomials. We classified polynomials so we could kind of know exactly what type we're dealing with. We talked about their degree. And then we also added and subtracted polynomials from each other. This week, we're going to look at multiplying them together. And then tomorrow, we're going to start doing what's called factoring, which is kind of like dividing polynomials or figuring out which two multiplied together to make a given polynomial. We'll start that tomorrow. Today, we're going to look at multiplying. And our objectives are to review classifying polynomials. We'll do that as we go. So we'll just keep reviewing them as we do examples. And we'll learn how to multiply polynomials together. And then we're going to mix together what we did last week with what we're learning today, which is to add and subtract polynomials after doing some multiplying. So nothing really new here, but we're going to multiply them together first, and then we're going to either add or subtract them together. And then I want to end with showing you this, the algebra tiles method of multiplying them. There's going to be a couple problems in our mastery test that you may get using algebra tiles to multiply. And it's kind of fun. It's a nice visual way to do the multiplying. So we'll do a couple examples of that. All right. Morning to everyone who just joined. Go ahead and grab your paper. We just got started, so you haven't missed anything. Today we're going to be multiplying polynomials together. Okay, didn't mean for this to all happen at the same time, but I want to do a quick review with you on just multiplying different terms together, especially terms that have variables. So at the top, x times x, how would I write x times x? Someone help me out with this if you don't mind. How could I combine x times x together and then use an exponent to show what that product would be? Should look familiar from what we did in Unit 1. How can I write x times x using an exponent and then no more like multiplication? Anyone have an idea?
Would you change the x to a 1?
Are you thinking anything divided by itself becomes a 1?
Yeah, kind of like that.
Okay. I see where you're going with that. It's that would work, Braden, when we were dividing. So side work here.
Oh, it's multiplication?
It's yes, sir. Since we're multiplying here, that rule wouldn't work for us. It would work here if we were dividing. But since we're multiplying, it's going to behave a little differently. Like literally what we have is, and Braden, thank you for answering, by the way. Thank you so much. X times X, right? Since we don't know what those numbers are, we can't actually figure out what that answer is, but we can combine them together using an exponent. Remember, here's a little hint. Let's say that we, or maybe Braden, maybe this is what you meant and I was off base, so forgive me if I was. Remember what we do when a number or a variable doesn't have an exponent? We can put a little 1 there. Now, maybe you'll see, not you, Braden, but everybody, maybe now you can see something we can do to combine these together. X to the first times x to the first. How can I rewrite those as a single term? X to the something. Any ideas? Did you guys all really forget this? We just did this in Unit 1.
Oh, Aaron answered in the chat. If you
Oh,
can see.
I'm sorry. Thanks, Aaron.
Is that yeah.
What did she say?
X to the power of 2.
X to the power 2. Aaron, don't be sorry. I just I wanted to stop checking the chat during my recording just because some people were sending me semi-private messages and I didn't want to record that on my screen. So my bad. Thank you.
Cool.
Thank you for responding. And yes, that's what I was looking for, Aaron, was X to the power of 2. So Braden, thank you too for jumping in with that. Just a quick reminder, when we multiply two variables together, like x times x, we would combine them to be x to the power of 2. Let's try the next one below that. I'm sure some people already did it. Let's say we had 3x times negative 2x. Now this time, it's basically the same as the first example, x times x, but we've got this 3 and negative 2 there. Can anyone help me out with how to simplify and combine those two? It's just like the first example, except we've got coefficients, right? We've got the 3 and the negative 2.
Wouldn't it be negative x? 6x.
Very good. Yeah, negative. Very good, Aaron. Thank you. Negative because one of these numbers is negative. And if whenever you multiply, if one thing is negative, then the whole answer is negative. So very good. It's negative. She said it's 6 because 3 times 2 gives us a 6. And then, of course, x squared again because we have x times x. So when we're multiplying two terms together, like these ones, do the coefficients. So 3 times 2. If one of them is negative, then the answer is going to be negative. Kind of goes with the multiplication for the answer. And then if you've got x's or y's or a's or b's, any variables, make sure to combine those together like we did with these last two examples. All right, thank you too for jumping in. Let's look at this other quick review, distribution, because we're going to be doing some of this today. Distribution in general in math means multiply everything on the inside by the outside. Multiply everything on the inside by the outside. So for this example, 5 times parentheses x plus 2. You've seen me do this with the little lines that I just drew, little arrows. That's just a nice visual reminder to help me remember I got to multiply the outside number by everything inside. So it's 5 times x. Best we can say for that is 5x. We don't know x, right? So we'll just write it together as 5x plus 5 times 2, which is 10. We can figure that one out, right? Because they're both numbers, we can do that multiplication. So this is an example of distributing the 5 to everything on the inside. Any questions on these reviews, please? All right, I'll wait a moment if anyone's still writing, and then let's look at multiplying polynomials together. Here we go. So here's an example of multiplying 3x times quantity, parentheses, x minus 8. So we've got to distribute our 3x to everything on the inside. When I say everything, I mean any term. So the x is a single term, and then the 8 or the negative 8 is a single term. So we've got two multiplications to do here. So 3x times x, if you think about that as like a separate problem, I'll write it off to the side. 3x times x. So 3 times 1, there's no coefficient for the x, right? So it's just saying like 3 times 1, 3. X times x would give us an x squared, or x to the second power. So there's the first part of my answer. And then we've got to multiply 3x times negative 8. So side work again. This time, there's just a single x, right? So we're not going to get an x squared. It's just x times negative 8. So 3 times negative 8 would yield a negative 24x. There's only one x there, so it doesn't get squared or moved up in the degree. And that's it. So really, this wasn't a polynomial because it was just a monomial, the 3x. Just to review our vocabulary from last week, 3x is a monomial. X minus 8 is a binomial. And what did we end up with? We ended up with another binomial because it's two items, two terms. So this is a binomial as well. Any questions on this multiplication, on this example, please? Okay. Let's look at another one. So I didn't make too many. I know that I've been kind of going over, going too long in these lessons. So I'm trying to dial that back a little bit. But also because I'm dialing it back on time, I'm going to kind of increase the complexity of the problems a little faster. So please ask questions. Here's example 2. It just says simplify the expression. What do we have? 2x times a trinomial this time. 2x times x to the second power plus 3x minus 10. So we need to multiply the 2x times every term on the inside. So we're distributing it to everything. That's three multiplications this time because there's 3 items inside the parentheses. So 2x times x squared. I'm going to do these as like 3 steps, and I'll do it as side work here on the right side. So 2x times x squared. Multiply the coefficients first. So 2 times no other coefficient is just 2. Now for my x's. X times x to the second power. How many x's total is that? This is 1, and this is 2 of them. And so I would group them together as x to the third power. So there's my first portion of the answer. Now the second one. 2x times 3x. This is like our review from earlier. 2 times 3 gives us 6, and then x times x gives us x to the second power. And then we have 2x times negative 10. And now here we have 2 times 10. Well, that'll be 20. One of those was negative, so it's negative 20, and one of those had an x, so that kind of goes with it along for the answer, so negative 20x. And that's it. We should stop and ask ourselves, can we do any combining like terms? No, we can't do that here. We have x to the third power, x to the second power, and then just plain x, single x. None of those can add or subtract. They'd have to be matching their powers for us to add them or subtract them. But soon we're going to see examples where there are matching powers after doing the multiplying. So then we have to like add those parts together to get our fully simplified answer. Okay, I'm going to stop real quick and ask to see thumbs for how people are feeling so far about these examples. Multiplying these polynomials. Okay, Keegan, I see that. Thank you. If everyone wouldn't mind turning on your camera for a moment and showing me how you're feeling about multiplying so far. Braden, thank you for telling me. Aaron, thank you. Delaney, I appreciate that. Thanks. And Leja, I see that. All right. So Bailey, Saeed, Manaya, Janessa, if you guys can tell me how you're feeling about it, I appreciate it. If you're still with me. All right. Let's try some more. Bailey, thank you for the feedback. Appreciate that. All right, folks, let's keep
I feel
going.
good about it. I don't know why my camera's not working, but I feel good about it because my camera won't turn on.
Oh, okay, no worries. Thanks, Manaya, for letting me know.
You're welcome.
All right, let's try the next one. Okay, now it looks a little more interesting. Here's example 3, x plus 3 times x minus 5. So this is a little different than the last two problems. This is a binomial times a binomial. So far, we've just had one number or term multiplied to a parentheses. But this time, it's like two parentheses together, multiplied together. So this is going to be more like, this is going to be where our focus will be for this whole unit, really. Let me show you how to do a problem like this. Remember, the rule for distribution is the number on the outside times everything on the inside. So if you have a problem like this with 2, it's almost like both of these, x and 3, are on the outside. So you're going to multiply x times both things in the second parentheses. And then we're going to multiply the 3 to everything in the second parentheses. So I'm going to write my little arrows out here. This shows you ahead of time, if you write your arrows to like show you the multiplication, this will show you, okay, I should have 4 different multiplications. X times x, x times negative 5, and then 3 times x, 3 times negative 5. And I'm going to do them all separately off to the side again. 4 multiplications. There we go. So starting here, x, and you know what? Let's list them all off before we do them too. So here's the first one, x times x. Then we're going to do x times negative 5. Then we're going to do 3 times x. And then 3 times negative 5. Okay. Now, x times x. Remember, how do we write that with exponents? Well, it's like x to the first, and we basically stack them up. We keep track of how many there are using exponents. So since there's 2 x's here, we write it as x squared. We're done. X times negative 5. Well, we can't really multiply x times negative 5 and get a whole number. Whenever there's a single variable, it's just going to be that variable for the answer. So x times negative 5 is just negative 5x. We write it as a coefficient now, negative 5x. 3 times x is just 3x. And then last up, 3 times negative 5 would be negative 15. So those are all the separate multiplications. And remember, they're all being added together. So now we're going to write our answer properly over on the left. X squared minus 5x. I would write it as plus, except it is negative 5x, right? So we're going to just make it as minus 5x. Now it's plus 3x. And then minus 15. Now I want you to scan through the answer, the problem, and ask yourself, are there any like terms here? Can I do any adding or subtracting? And this time, yes. This time I have negative 5x and plus 3x. So we're going to combine those together as negative 2x. Can't do any simplifying with x squared or 15, so we're done. And I'll circle that, box that as our answer. Any questions or concerns or comments? The takeaway from example 3 is that everything in the first parentheses should be multiplied to everything in the second parentheses. All right, I'm going to move on to example 4 in just a few moments. Okay, here's example 4. This is two trinomials, two three-termed polynomials multiplied together. So it'll get a little messy looking with our arrows, but I'm going to show you what that would look like. So the first term here, x squared, that needs to be multiplied to everything in the second parentheses. Like this. And then we're going to have 4x multiplied to everything in the second parentheses. And then we're going to have 1 multiplied to everything in the second parentheses. Then we write them all together and we add or subtract like terms. And then we're done. So I'm going to do it the same way I've been doing it. Off to the side, we'll do all the individual multiplications. All right, so x squared times x squared. Okay, so think about it this way. You've got two x's and then two more x's all multiplied together. So we write that as x to the 4th power. Remember, we can add the exponents from unit 1. Add the exponents. Now we've got x squared times negative 5x. It's 5x. So that'll be negative 5x to the 3rd. Then x squared times 3. That one's just going to be 3x squared. So there's our first 3 terms, but we've got to do the 4x still, and then we've got to do the 1. So I'm going to write down what we have so far. Okay, now the 4x. So 4x times x squared. Remember, it's everything in the first parentheses. Now we're on 4x. Gets multiplied by everything in the second. So 4x times x squared. 4x to the 3rd. And I'm going to add that to my list of my solution over on the left too. 4x to the 3rd. Now 4x times negative 5x. Okay, 4 times 5 gives us 20. One of those is negative, so it's negative 20. And then x times x gives us x squared. So negative 20x squared. And then 4x times 3, that one should be fast, 12x. Okay, and I'm running out of room, but we've still got to do 1 multiplied to everything in the second. The good news is 1 times everything in the second, parentheses, is just going to be all those terms. But I'll show what that would look like. 1 times x squared, that's just x squared. 1 times negative 5x is just negative 5x. And then 1 times 3 is 3. So I've got to add those in on the left side. So plus x squared minus 5x and plus 3. So this whole string on the left side, that's our answer. However, we can do a bunch of simplifying because we have a bunch of matching variables. So x to the fourth is our first variable. Scan through your problem. We're looking for any other x to the fourths to add or subtract. You should see that there's no other x to the fourth numbers. So below, I'm going to write my final simplified answer. So there's my x to the fourth. Then scan through for x to the third. So here's one. I'm going to underline it. Here's another one. And that's it. So we've got negative 5x third plus 4x to the third. So that's negative 1x to the third. And we're not going to write the 1. We're going to write it as just negative x to the third. But that's my negative 5x to the third plus 4x to the third. Now let's do squareds or second powers. So there's 1, here's 2, and here's 3. So I underline those with a squiggly. 3x squared minus 20x squared plus 1x squared. So that's 3 minus 20 plus 1 should be negative 16 x to the second power. Okay, last up, no, not last up. We've got our single x's, so 12x and negative 5. 12 minus 5, 7 plus 7x. And then lonely 3. There's no other whole numbers, just the 3 there. So we'll include it, plus 3. And finally, here's our answer. So yes, there's a lot to keep track of if we're multiplying two polynomials together. But the work we're doing is really just multiplying one or two terms at a time, two smaller things at a time. All that stuff I have on the right side, just multiplying two terms together. Keep track of your exponents if it has any, and we add them up. We stack up the exponents. Any questions or concerns, please? Does anyone need more time? Just let me know. Otherwise, I want to move on to number 5. Okay, here we go. Simplify the expression. This one looks different. We've got a negative or a minus sign, and then x minus 7 times x squared plus 2x minus 4. So if you see a problem like this, start by distributing the negative to inside the first parentheses. Here's what I mean. I'm going to take this negativeness on the outside, and I'm going to basically distribute that to all the terms in the first parentheses. We don't do the whole problem because this is like a minus 1, okay? Minus 1 times x minus 7. And if you multiply it into one of the parentheses, it's been used up. So we're going to multiply it into just one of these parentheses. I like to do the smaller one. And it's lined up that way. So let's rewrite our problem. This becomes negative x plus 7. And I'm going to carry down the other one, the other parentheses. Okay, now we're going to multiply negative x plus 7 to everything in that second parentheses. So we should have 6 different multiplications because it's negative x times everything and then 7 times everything. So negative x times x squared will be negative x to the third. 1x and then 2 more, x to the third. Negative x times 2x will be negative 2x to the second. And then negative x times negative 4. Remember, negative times a negative makes a positive, so that's positive 4x. And now for the 7. So 7 times everything in the second parentheses. So that's plus 7x squared plus 14x and minus 28. Now, we've successfully multiplied. Now we have to see if we can add or subtract any of the terms. There's only the single x to the third term, but I see x squared and x squared. So those will combine. Negative 2 plus 7, those will combine to 5x squared. So let's write that down. We've got negative x to the third plus 5x squared. Our x's, 4x and 14, that'll be 18x. And then lastly, negative 28, or minus 28. And we're done. All right, no questions. Let's try number 6. All right, take a moment and copy this down. 2x times negative 5x plus 1. Okay, then minus 4 times x minus 3 times x minus 6. So this starts off as like two different big multiplications. So we've got the 2x times its parentheses. We got to deal with that. And we've got 4, or negative 4, times x minus 3, and then times another x minus 6 there. So we'll have to do this in stages or steps. So let's start with the 2x and then the minus 5x plus 1. So 2 times negative 5, that'll be negative 10x squared because we have x times x. Then 2x plus 1, okay, that's, or times 1, that's just plus 2x. Okay, now we've got this. I'm going to write down the whole thing here. We haven't done the second multiplication sets yet. I'm just going to copy these down. Okay, now the truth is the order that we multiply this stuff together doesn't matter. But since we've got this negative 4 times x minus 3, why don't we do those first, multiply those together, and then we'll multiply that product to x minus 6. So negative 4 times x minus 4x. Negative 4 times negative 3 plus 12. And let's see, that is all going to be multiplied to x minus 6. Even the 4x, the negative 4x. Okay, so let's do that now. Okay, so negative 4x times x, negative 4x squared. Negative 4x times negative 6, positive 24x. And now the 12, and we're finally done. 12 times x, 12 times negative 6 is negative 72, I think. Scan for any adding we can do. So negative 10x squared can go with this negative 4. So that'll be minus 14x squared. And then we've got 3 terms this time that have x's. So add those all together. 2 plus 24 plus 12. 38 plus 38x and then minus 72. And we're finally done. All right. Any questions? Please. All right. Let's do number 7. This is actually a much easier problem than the last one, than number 6, even though it looks different. Example 7, simplify the expression. We have x minus 10 squared. The whole parentheses is being squared. So what does it mean to square something? It means two of those items are multiplied together. So if you see a binomial, x minus 10 being squared, it means this, x minus 10 times x minus 10. And it's,
Did you want the answer?
oh, does someone have it already? Please.
I don't know if I'm right. I might be wrong. Is it x2 minus 20x plus 100?
Yeah. Good job, Anaya. High five. Boom. Yeah, so what she did was she squared x minus 10. And so just following the same format we've been doing the first 6 examples, we would get x squared. Then we get minus 10x because x times negative 10. And we get it again. Let me show you where that's coming from using our arrows. So x times negative 10, and then negative 10 here times x. So we get 2 of them. And then we get negative 10 times negative 10 for a plus 100, like Manaya got. Then she combines those two like terms that are both x's to negative 20. Awesome. Thanks, Manaya. Any questions, concerns on this example? No questions. So next up, I wanted to show you the algebra tiles way of multiplying polynomials. Now, it's a little weird because we're going to draw them instead of like play with physical ones on our tables or something. However, it still works, and it might be useful if you want to use it as an extra way to do these problems. So I want to show it to everybody. So algebra tiles method of multiplying polynomials. Suppose we need to multiply these two binomials together, x plus 2 times x plus 3. So we can do it the way we've been doing it in the last 7 examples. Just multiply everything in the first to everything in the second parentheses. Or we can try using the algebra tiles method. All right, I'm going to cover that up to move that out of the way. So here's how we do it with the algebra tiles method. We're going to draw out on paper or on my screen here, x plus 2. And then we're going to draw on the side x plus 3. So here's how we do that. So make bars for your variables. So I'm going to make this like rectangle, a bar, and I'm going to label it x. And I want to have x plus 2 being shown visually. So here's my 2 now. I'm going to show it as a 1 square, and then next to that, a 1 square. So this row right here represents x plus 2. Now, on the side going vertically, we're going to show x plus 3 in the same way. But we're going to use the 1 square in the corner as one of our 3's. And here's what I mean. So this will be 1. That's already there. And then above that, we write a 1. And above that, another 1. This represents my plus 3. And above that needs to be an x. And it's a bar, the same. It's okay if it's not perfect, but try to make it the same as like the first x we made, going upwards. So now on the side, you see this represents x plus 3. Okay, so now to finish this off, we change to yellow quick. What we're going to do is kind of like playing Battleship or something. We're going to multiply all the stuff on the bottom row by everything on the side column. So, for instance, in this corner here, we have this 1, and that needs to multiply to everything along the side column. So 1 times this 1 would be 1. 1 times the next one above it right here, that's also 1. 1 times 1 is 1. Then 1 times the x bar is the x bar. 1 times x is x. So I'm going to draw in that. Okay, that's done. Now we have to do the x bar to everything on the side column. So x times 1 is x. So draw in a new x bar above it. X times 1 is x again. And then finally, x times x, on the outsides, my x down here times this x on the side is x squared. So we draw that as a square that has an area of x on the bottom and x on the side, x squared. Now our final step is to basically add together all the like terms from this like grid that we made. Let's do it. For me, I think I like doing it as coefficients, like the whole numbers, and then the x's and then the x squareds. So let's kind of add up all of our ones first. So 1, 2, 3, 4, 5, 6. So here's my answer off to the side on the right. Now the x's, 1, 2, 3, 4, 5 x's, so plus 5x. And then x squared. And there's our answer. This is a visual way to multiply our polynomials together. It's a little tricky, but all we need to do to try it is to take the first multiplier factor, x plus 2. We draw that out along the bottom like I did, and then you do x plus 3 on the side. And notice in the red how we started it, that single 1 in the corner is used for both. So what we're making is like a big square or a big like rectangle shape. And then you multiply all the things on the bottom to all the things on the side, going up and to the right, up and to the right. I hope I didn't bother too many people with this. I have one more example to do like this. We may as well do it for practice.
Thank God, is there more examples? Because I got so confused.
There's another example for this. And you know what? We could do all of our previous examples using this, except, yeah, we could do all of our previous examples using this formula. And thanks for letting me know, Leisure. Let's try another one right now. Let's try another one. So I'm covering up the top, but it just says, oops, algebra tiles example 2. And here's our practice example. So we're going to multiply x plus 2 times x minus 1. We're going to try a minus 1 this time instead of a plus. Now, if we did this by hand without the algebra tiles, I think it'd be a pretty easy one to start with, right? It's x times negative 1, and then 2 times x, 2 times negative 1, add them all together. Let's try it with algebra tiles. So x plus 2, I want to show that along the bottom. Make a bar for x, and then little squares for my plus 2. But remember, you don't do a single square. You do them as all ones. So here's plus 1 and then plus 1 again. So this is my x plus 2, just like last time. Now I need to show x minus 1. And this is a little tricky because I want to use this space right here, folks. I'm going to do it, kind of highlight where I want to do my next polynomial, right above that plus 1 that's already there. However, I need to have it say x minus 1, right? So here's how we kind of fix that. I'm going to say a minus 1, and then I'm going to do a minus 1 again. Because what happens if I add together that column? I'm going to do that real quick on the bottom. That's -1, -1, +1. If we add all those together, 1 minus 1 here, those two cancel, and we're left with -1, which is exactly what we want for our second polynomial or binomial. And what did I miss? I didn't do my x yet. So let's throw in an x bar here. Now we're ready to multiply. Let me change my color. Try orange. So just like last time, we're going to multiply everything in the bottom row. So for instance, we got to multiply this guy here and this guy here by everything that's like exposed to it above and to the right. So for instance, kind of like imagine arrows going up and over like this. So 1 times -1 is -1. 1 times -1 again, -1 again. 1 times x, x. And now we do it again for that x bar on the left side. So x times, and what we're multiplying by is just the column on the far right that we started with. So it's going to be x times this -1x, and then again here and again up here. So this will be negative x. X times -1, negative x. X times -1 again, negative x again. And then x times x is our x squared. And that's always going to happen. If there's ever x times x, we're going to have a big square that's labeled x squared. And now what we're doing is adding up all these little boxes I've got by like terms. So focus on just like the whole number, the ones. Focus on just the ones first. -1, -1, -1, -1. That's all -4 plus 2. So that's -2. So up here, there's my answer, -2. Now the x's, negative x. Oh, you know what? Let me do it with the red. Let's do this. Let me show you this. Okay, I'm going to cross them off, if that's okay. So a negative x combined with a positive x, those cancel. Negative x, positive x up on the right will cancel. And what's left for x? Just a single x, right? So that's plus 1x or just plus x. So here I'm going to do my answer in red. So we already had -2. We've got plus x. And then, of course, there's x squared. And that's everything. And that's our answer. And if we had skipped doing it this way and we just wanted to multiply them out the normal way, the first way I showed everybody, we'll still get the same answer. X times x is x squared. X times -1 minus x. 2 times x plus 2x. And 2 times -1 minus 2. Combine these two in the center. That's a plus x. So we get x squared plus x minus 2. So doing the algebra tiles method is just another way to multiply polynomials. You can do it either way. Excuse me. Pardon me. So that's it for today. That's it for today. Everything that I showed you in this lesson is going to be the type of problems you could see while taking the mastery test. And this mastery test is called multiplying polynomials. It's the second test in Unit 2. That's today's homework. Since we've only got a few minutes left, what I'd like to do is I'd like to just tell you all, do your homework today. Try doing your mastery test today. I would say start it right now while you're doing your math with me. Just start it now, even though we've only got about 7 minutes left. But we also, would anyone like to just do more problems together like this? Add on some more examples or any questions from any of today's examples that we've already done?
I got like a better grasp on things, Josiah. but like if like another day I feel like I can't do it or I'm more confused, is there any way I could just like tomorrow on Tuesday after 3 when you have your class and ask you more about it?
Of course. Of
Okay.
course. I would love it if you came at 3 o'clock tomorrow. That goes for everybody.
Yeah, I think I'm going to. It's a
Awesome.
little hard. Yeah.
Okay, and here's another thing I want all of you to do is try your mastery test today. It's called multiplying polynomials, and there should be a practice there too, like or an application, something right before the mastery test. Go ahead and do that too. That'll just be more practice. It doesn't count against you, and you can try that like either before your mastery test or as well as your mastery test, just to see more examples and get some practice doing them, and then compare your answer to whatever Edmentum is saying it is. So I'd encourage everyone to do that if you're a little iffy on today's lesson. And then also you could go onto YouTube and just search for multiplying polynomials. You'll see other math people doing it, hear their explanations, and it might be good to just get perspective. So you're not only hearing it from me, but some other minds as well. So I would encourage you to spend a few minutes looking it up on YouTube. I would say also do the application and get some more practice there. And then we will meet again tomorrow. So I'm going to go ahead and let me really quick just double check my attendance with you all.